All right, so we have the 16th lesson. We have a very interesting problem today. We are still dealing with integration. This one is second derivative. dy dx is the first derivative written this way. The second derivative like this is this one. So once you see this one, it is also differentiation. Differentiation. First derivative, second derivative. But the second derivative is given as what? Is given as 2. The second derivative is given as what? 2. It's given as 2. All right. And the first derivative is 0. This is not a derivative because there is nothing here as a prime. F of 0 is minus 8. Then we want to find f of x. So one thing I want you to know is, let's say we have y equal to x cubed minus 3x squared plus 4x minus 1. Pay attention. If we find dy dx, this multiplies this, we have 3x squared. This will give us minus 6x. We've come so far. Huh? We've gone far now. For me to tell you again, this times this minus this, we did all that. So if you are seeing this for the first time, remember this is the 16th class. So you are missing 15 lessons. So this is plus 4. First derivative is this. Pay attention. Now if we continue differentiating, this will become higher. Yeah, it will become the second derivative. So this will give us 6x minus 6. Yes. So what does this one tell us? We are given the second derivative. Now look at the second derivative is this. If you have the second derivative, you want to take it to the first derivative, you integrate. You integrate for it to take you here. Now if you integrate, if you remember the principles of integration, 6x minus 6, what do? We add 1 to the power. If we add 1, this becomes 2 divided by the new power. If you are integrating a constant, just give it x. So this one will give you 3x squared minus 6x. 3x squared minus 6x. But you cannot get this one again. And that is the reason we usually say plus c. Because they know that there is a missing value that you cannot get, except if there are limits. So moving from second derivative, reversing to the first derivative, you integrate. First derivative to the normal function, what do? We integrate again. I hope it is clear. Okay. So if that be the case, we integrate this one for us to get what? The second derivative. So, for us to get the first derivative, dy dx means the integral of 2. You see, we integrate. So this dy dx will give us what? If you integrate a constant, just 2. What is the integral of 2? Is 2x. Whenever you are integrating a constant, give it this variable x. But there are no limits, so you say plus c. But how can we integrate now for us to take it to the normal function? Because we need a normal function. It is now in the first derivative. Mind you, this one you see implies this. So many students are familiar with dy dx other than this format. So this one dy dx implies the first derivative. And this first derivative, f of x. Okay, we are not given f of x, but we are given the first derivative of at what 1 is 0. So why do you think we are given the first derivative at 1 to be 0? Because they want us to find this constant. So let me remove this one for you so that you don't get confused. So this one is the same as this, 2x plus c. I hope you are following. Okay. Now, look at the first derivative at 1 is 0. So let's say first derivative at 1. So 1 is going to replace x here. So this is 2 times x. What is x? 1 plus c. But this first derivative at 1 is given as what? 0, which is 0. So this implies 2 times 1, 2 plus c is 0. C is equal to what? Minus 2. I hope it is clear. Very interesting why question. Okay. So what is the essence? Because we don't want to see this c. So now we can say this first derivative, it is now complete. Instead of c is not minus 2. But the question is this the actual f of x we want to find? No, this is just first derivative. So now for us to take it to the normal function, we integrate again. Okay, so what do we do? Divide the x. Don't be confused. This second derivative is this one. This first derivative is this one. I just want to replace this one with divide the x, which most students are familiar with. 2x minus 2. So what do we want now? We want the final f of x. We want the final f of x. So we say the final f of x is by integrating this. 2x minus 2 dx. I hope it is clear. So f of x is equal to, integrating this, we say 2x. There is 1 here. If you add 1, it becomes 2. That 2 comes down. If you integrate a constant, give it this variable. Are there limits? No, there are no limits. So we say plus c. So we say f of x is equal to x squared minus 2x plus c. But must the f of x required for us to find come with a constant that is unknown? No, it must not come with that one. So what do we do now? That is why we are also given f of 0 to be minus 8. So we say f of, this would have been the answer if not because of c. So f of 0 is equal to, for every x we see, we write 0. So this is 0 squared. This is 0 plus c. Don't you think everything here is 0 minus 0, 0? What remains is c. But this f of 0 is what they say is equal to minus 8. Is minus 8. So therefore our c is minus 8. What do you think we decided to find the value of c for? Because instead of this one being the required f of x, this one disqualifies it, this c. So now we get c. So we use minus 2 to replace this c to get our final f of x. So finally, f of x is equal to x squared minus 2x. What is c now? Minus 8. So this is our final f of x. Thank you for watching. Do not forget to follow, like, share, and comment. Also subscribe to the YouTube channel.